Hello everyone. Today we're going to be solving math problems, and we have the integral from 2 to infinity of 3 over x squared minus x dx. Now before I begin, I'd like to admit this series was inspired by Blue. Great shout outs to him. He really helped me out on some math problems. So I'll try returning the favor. Here we go. There will be two methods of solving this problem. First, I'll show you integration by partial fraction method, and then I'll show you a different method that does not require the use of L'Hopital. Okay, let's begin. 3 over x, well, this thing can be factored out to now for partial fractions, first we want to create what our goal is. So our goal is going to be a over x plus b over x minus 1. Now, we can use this to work backwards. So ax minus a, we're actually just multiplying cross multiplication to get the same denominator. You know how it is? Plus bx all over this thing. All right, now that we have this, we have to factor out the x. The reason we do this is so we can know which the x terms are and which the constant terms are. So we have a times x plus b, because we have a and b, plus, we're doing plus, don't worry about it, we can just use parentheses, negative a. Let's move over the phone. There you go. So a plus b would equal what? You guys stop and think. What do you think x term is here? It would be 0 since there's no x there. So we're going to go back. A plus b is 0. Now since our constant term is negative a, okay, look back what our constant is. 3. There you go, we have 3. Now we use basic strategies, add them together to just find out what they are. So a, negative a, gives you 0a. B plus nothing just gives you b. 0 and 3. B gives you 3. Plugging b back into the original expression, a would give you negative 3. There you go. Now we have this solved, a and b. We can actually write it out. So a is negative 3 over x plus 3 over x minus 1. Now we would actually have to integrate this expression from 2 to infinity. So 1 over x is just ln, so we can write that here. There you go. We don't have to include plus c because this is a definite integral. And for definite integrals, we do not need the constant of integration. All right. Now, from here, what we may think is, yeah, let's plug in infinity and 2 and find out what our answer is. So let's try doing that. Negative 3 ln of infinity plus 3 ln of infinity minus 1 is still infinity, guys. Okay? So ln is this. E to the power of what gives you, what's inside here? Infinity. So e to the power of infinity would give you infinity. So that would be the infinity minus infinity indeterminate form. So we cannot use this form of the expression. This is where the hard part begins, because we're going to have to use some pretty complicated log rules. These are the log rules. So if it's added together and it has the same base, log b, then it's actually times on the inside. If it's subtracted, it would be divided by. And if it's a constant multiplied by the thing, then it's actually to the power of, as you see here. These are the only ones that we'll be using for this problem. Actually, we might not even need to use the rule 2. Don't worry about that. So rule 1 and rule 3. Memorize those, guys, and you'll be good for the AP test. Now let's go back to our problem. So infinity, indeterminate form, and we can't use LHR, L'Hopital rule, because it's not F over G. And I don't know how to make it that form, so instead we're going to be using log rules. So back here, if it's constant times this, that's to the power of, which would give you ln x. So to the power of -1, we're going to do that first. 1 over x, and there, we still have 3 left over, plus e to the power of 3, so x minus 1, make this in parentheses, to the power of 3. There you go. Hold on, I'm starting to think there's a easier way. I'll show you guys if it works after this, because I don't think you have to use the 3, but we'll just use it for now. So now, this to the power of 3. This. Now, if you guys would remember the log rules, if it's added, it's actually multiplied. It's a pretty dumb rule, but you have to memorize them. ln of x minus 1 to the third over x to the third. There you go. Now, in order to, well, now let's just try plugging in to an infinity to see if it works. So infinity minus 1 still infinity. And infinity to the third, still infinity. Still a discontinuity. But at least we got it into the F over G form. From this, we can actually start doing work. Now, I did realize I made a mistake. So 3, and this is also going to be 3. I think it would be easier to just factor out 3. But I'll show you guys that later. I'm just showing you what I did first. So then I actually solved what that is. And if you solve that expression, you get x to the third minus 3x squared plus 3x minus 1. Plug that into there. Then you divide it by x to the third. As we said, we're going to use L'Hopital rule. So let's just find a derivative of the top and the bottom. So 3x squared minus 6x plus 3 over 3x squared. If we use L'Hopital again, it's going to be infinity over infinity. We're going to have to do it a couple more times, guys. Bear with me. And if we just keep doing it, it's just going to boil down to 1 over 1. Because since this term and this term are the same, it's always going to be infinity over infinity until it's 1 over 1. I did this manually, but that's a faster way. So 1 over 1 is what you get from this. So it'd be 1 minus, and then we plug in 2 into the equation. ln of, just use this one because it's easier. So 2 minus 1 gives you 1 to the third. And plug in 2 to the third, it gives you 8. And that gives you ln of 1 over 8. And that's going to be our final answer. Now, let's see if I actually did have to factor out the 3, because I think that might be a faster strategy. So let's try doing that. Memorize that. Let's see if that makes it a whole lot easier. I feel like it might. So if it's added, it's multiplied. Remember that. Yeah, so basically it's the same thing, but it'll give you the answer a bit faster. Let's see. So it'll be 0 minus So plug in 2. 2 minus 1 gives you 1 over 2. If you plug this into the calculator, it should give you the same answer as negative ln of 1 over 8, since 3 to the power of this, of 1/2, is 1 over 8. So that checks out. I should have done this on my first go. I didn't think about it. Now I did. Thank you. Now, let's move on to method number 2. All right. Now this method uses u sub rather than integration by parts. Now you may be wondering, how do we do u sub on this? Like what? That's insane. Well, when I was looking for the answer on Google, I found this, and it might be pretty helpful. So we can actually factor out the bottom, x squared times 1 minus 1 over x. Now this works because x squared times 1, x squared times this gives you negative x. So now we can do u sub. In this situation, u would be 1 minus 1 over x, while du would be, this one doesn't matter for du, so 1 over, add 1 to the exponent, divide by the new exponent, 1 over x squared. Oh, would you look at that? 1 over x squared. That's what we have here. Now, it'll just be, oh yeah, do you want to put dx? There you go. I don't really use that, but 3 over u du, and that'd be 3 ln of u there you go. Now we can plug in the values to an infinity. Let's try that. So 1 minus 1 over infinity, anything over infinity gives you 0. 3 ln of 1 minus, now we plug in 2. 1 minus 1 over 2 gives you 1/2. Factor out the 3 times ln of 1. Oh wait, ln of 1. E to the power, there, I'm back in the groove. E to the power of what gives you 1? 0. 3 times 0, 0. Now, e to the power of what is 1/2? We can't do that. It's pretty hard. So it's just negative 3 ln 1/2. And that is the same thing we got from the other method, which is also equal to this method if you plug it in. Hope you guys enjoyed my video. I hope that helped. And see you guys on the next one. Post-game interview. Here, I just realized when I was editing the video, x minus 1 over x, there's 2 ways you can go about this. You can either do L'Hopital rule to get 1 over 1, or the second way, you can factor it, x over x minus 1 over x. X over x, same thing as 1 minus 1 over x. This is the same thing, 3 ln of 1 minus 1 over x is the same thing that we got in this one. And that's how it's all connected.